All right, solving trigonometry equations. The key to solving trigonometry equations is number one, understanding all of your identities, and then number two, understanding angle of any magnitude. Now, once you have a good understanding of these two things, solving any question on trigonometry will be quite simple. Now look at this particular question. This is a very simple example, and we'll start from here, then we'll move on to the much more complex versions of trigonometry equations. Now you see in this particular one, we have 1.3 tan theta minus 2.5 equals to 0. And we're told that we're supposed to solve for values of theta between 0 degree and 360 degree. So how do we go about solving this? All right, this is quite simple. You use your understanding of algebra to go about the first step here. So we know that 1.3 tan theta here will be equals to, when you shift this to the other side, will be equals to 2.5. And then the next thing to do is tan theta, you divide both sides by 1.3. So tan theta will be 2.5 divided by 1.3. In this place, you would have to make use of your calculator, and that will be 2.5 divided by 1.3. What you have there is 1.930. So tan theta equals to 1.9231 rather. Now, this is where you would have to apply your knowledge of angle of any magnitude, which we have done in a previous topic. Now, I told you that when you have a question like this, of course, in this case now you can see the tan of an angle was positive 1.9231. I said the first step to do, the very first thing to do is to go on and solve for theta being arctan. Now, in this case, you will ignore whatever sign was here. If it was minus, if it was positive, you will ignore it. You will just write the 1.9231. So if you do arctan of that, the arctan of 1.9231, you'll be getting the value of 62.5. So theta here was 62.5, but as I told you already, you cannot conclude your values for theta to be 62.5 because you have to go on to investigate from your quadrant. Your quadrant is what determines what your final answer will be. So in this case now, if you check through with your quadrant, all student takes calculus. In this case now, we are having the tan of an angle, and the sign we are dealing with here is the positive sign. So we are asking ourselves, where is sign positive? Of course, sign is positive in the first quadrant where all of them are positive, and in the third quadrant. So if you go on to write that out, so we have quadrant 1 and quadrant 3 as the quadrant of interest. So what you have to do next is to find a way to solve it. Now, for our quadrant 1, I told you already that what you have to do is to just replace whatever your theta value was here. This will be 62.5 degree. So whenever you're dealing with quadrant 1, you just replace whatever you have gotten here back here. But for quadrant 3, we have theta plus 180 as what the rule that happens in quadrant 3. And in this case, our theta is 62.5. That will be 62.5 plus 180. If you do 62.5 plus 180, you get a value of 242.5. 242.5. So in this case now, we have both of our answers as 62.5 and 242.5. Don't forget I told you, whatever you got here doesn't represent what your answer will be. You have to use your quadrant to make your final answer. Now, in the case where you have quadrant 1 being featured, then you can go on to fix in whatever you have gotten here in your quadrant 1. But in any other case, if quadrant 1 was not featured, this value will not be part of it. Let's try and solve some other questions very quickly. So let's quickly look at this particular question. We're told to solve the following equations. And I told you already, the two basic skill you must have, number one is to know your trig identities, and number two, you have to be able to solve angle of any magnitude. In this case now, we're told to find the value for theta between 0 degree and 360 degree. So let's try and solve question number one very quickly. We have sec square theta was equals to 2 tan theta. So what do you do when you have questions like this? The very first thing, as I told you in a previous video, is you must make sure that every of these trig functions is just one trig function represented here. Now we have tan theta as a trig function, we have sec theta as a trig function. It's literally impossible to solve this way. You have to find a way to express this whole equation with just one trigonometric function. And what you have to do for you to be able to express that is to make use of your trigonometry identities. Now, we have 7 basic identities, which we'll be using one of them for this particular question. In one of our identities, we know that sec square theta is equals to 1 plus tan square theta. So this is one of our trig identities, which we have talked about in a previous video. Now, this sec square theta equals to 1 plus tan square theta gives me the opportunity to be able to change wherever I saw sec square theta into this particular value. That way, I will then have just tan theta being featured rather than just having two different trig functions. So here I can go on to fixing my, always use your brackets as much as possible. So you can see what I've done right there. So wherever I saw my sec square theta, I have filled it in with this particular identity, which is this. Now I can go on to open this. This is 1 plus tan square theta equals to 2 tan theta. It's always very good practice to always make use of your bracket every time. So looking at this now, I can go on to make this, bring all these things to one side of the equation, because I can deduce already that this is taking me towards a quadratic equation. So looking at what we have here, I can have tan square theta. Bringing this in, I have 2 tan theta. I brought this in here to the left hand side. Of course, this is plus 1 equals to 0. Now, if you can look very carefully, you would see that this looks very much like a quadratic equation. Let's decide now, so you can probably see more clearly. Let's decide to represent, let's represent x as tan theta. So you will be able to see what I'm saying more clearly. So if x was tan theta, that means tan square theta will be x squared, obviously. And this will be minus 2x, then plus 1 equals to 0. So you can see that this is now very much like what you are very used to. Looks very much like, it's not very much like, it actually is a quadratic equation. So what we need to do next is to solve the quadratic equation. So if you want to solve this equation, obviously, you can go on to split this using factorization technique. You will have x squared minus x plus 1 equals to 0. This will be x minus 1. This will be x minus 1 equals to 0. So here we know that x minus 1 equals to 0, and our x here will be equals to 1. Obviously, twice. It happens twice. So don't forget that our tan theta was x. So obviously, we can go on to say our tan theta equals to 1. All right, so you can see from here that since our x was tan theta, so we can go on to say tan theta equals to 1. So tan theta being equals to 1, in this case also, let me quickly tell you, we are going to still be using angle of any magnitude. In this particular case now, all All right, don't forget I said the two skills you need for solving questions like this is number one, understanding your identities, and number two, knowing how to solve angle of any magnitude. When you get to this particular place in any question on trigonometry, you then need to apply your angle of any magnitude. Don't go on to just say theta equals to arctan 1 and that's all. Don't forget the condition they gave you was that you're supposed to find for values of theta between 0 and 360. If you're finding just arctan 1, that means you're just finding for only between 0 and 90 degree. But when you have to find between 0 and 360, you have to investigate using your quadrant. So in this particular case now, the first step I told you to do when using angle of any magnitude is for you to go on to solve arctan 1 initially. In this case, you would have theta being 45 degree. Now, I told you that this doesn't mean this will be part of your answer. So you would have to go and investigate using your quadrant before you can conclude on your final answers. So investigating using the quadrant, we have all students take calculus. And for our tan, being positive, this is a positive one. We have the first and the third quadrant being represented. So obviously we can go on to identify quadrant 1 and quadrant 3 as our quadrant of interest. So for our quadrant 1, I told you already what you have to do is to just fix in the value of theta being 45 here. So our theta is 45 in our first quadrant. For our third quadrant, we have theta plus 180, and that will be 45 plus 180. That will be 225. So this gives us both of our answers as 45 degree and 225 degree. So that's that about question number 1. Let's try and solve question number 2 very quickly. So for question number 2, we have 2 cos squared theta being equals to 1 minus sine theta. Now, in this particular question, you have to go on to make use of your identity first. I told you the two skills, getting your identities right and knowing how to solve angle of any magnitude. Having these two skills will set you up for solving any question on trigonometry. So in this particular case now, I want to change. This is a trigonometric function cos theta. This is another one sine theta. We can't have this. We have to dissolve everything to just one. So what I see is possible here is that I can change cos squared theta to have sine squared theta. That's the most feasible direction to move through with. So, but I remember that my sine squared theta plus cos squared theta will be equals to 1. This is from our identity. So I can go on to say cos squared theta will be equals to 1 minus sine squared theta. So in this case now, I fix in this particular, what we have gotten here, this equation here. I fix this here for our cos squared theta. So I would have 1 minus sine squared theta. Don't forget I'm fixing wherever I see cos squared theta to represent 1 minus sine squared theta equals to 1 minus sine theta. So in this case, I have 2 minus 2 sine squared theta equals to 1 minus sine theta. Now I can go on to arranging this properly. And if you do that, you have 2 sine squared theta plus sine theta. Then this is plus 2. Then bring this in, this will minus 1 equals to 0. You can see this looks very much similar to that of a quadratic expression. Obviously, 2 minus 1 will be 1, so I can change this to 1. One other thing I want to do is, because it's not very proper to start an equation with negative, so I want to go on to multiply through by minus so that I can make this start with a positive sign instead of a negative sign. So multiplying through by minus, I would have 2 sine squared theta minus sine theta minus 1 equals to 0. So again, this already looks like a quadratic equation. If you decide to take our sine theta, if you take sine theta for x, what you'll be having would look very much like what you are very used to, and that would be, you will be having 2x squared minus x minus 1 equals to 0. Of course, putting x as sine theta, and then you can go on to solving this using your understanding of quadratic equation. So if you have to solve this using quadratic equation, factorization will give you a result of this. So you will be having 2x bracket x minus 1 plus 1 into bracket x minus 1 equals to 0. So obviously 2x plus 1 and x minus 1 equals to 0. So from here, you can see that our values are 2x plus 1 equals to 0 or x minus 1 equals to 0. In this case, our 2x will be equals to minus 1 or x here will be equals to 1. X here will be equals to minus 1 over 2 or 1. Now, don't forget that our x represents our value for cos theta, for sin theta rather. So sin theta was represented as x. So we can then go on to replicate x now being sin theta. And what we'll be having will be sin theta, because don't forget sin theta was x. So for having x equals to 1 minus 1 over 2 or 1 will mean that our sin theta for this case will be minus 1 over 2. And for this case, when it was 1, or our sin theta will be equals to 1. Don't forget x was sin theta. So we can then go on to make this into decimal just for the sake of easy calculation. Minus 0.5 or our sin theta equals to 1. So what you have to do in this particular case is to go on to then resolve using the angle of any magnitude. So I told you already, this is one major skill you have to know in order for you to be able to solve trigonometry equations. So angle of any magnitude, I told you already, the first thing to do for this, you'll be having two different situations and you have to solve them separately. You have to solve this, then you solve for the sin theta equals to 1. In this case, now what you have to do initially is to find theta being arc sine. I told you already, the first step, you have to ignore the sign. So you just put arc sine 0.5. So when you put arc sine 0.5, what you'll be getting as your theta there will be what? When you have the arc sine of 0.5, what you have is 30 degree. So our theta here was 30 degree. And I've told you that 30 degree doesn't necessarily have to be part of your answers. You have to, your quadrant is what will determine in eventually what your answers will be. So go on to investigate from your quadrant. From a quadrant, we know that all students take calculus. So we are looking at our sign. We're dealing with sin theta. And this is a negative sign here. Don't forget, there's a minus here. So you're looking for where is sign negative. Sign is positive in first and second. Obviously, is negative in third and fourth. So our quadrant of interest is the third quadrant and our fourth quadrant. Those are the two quadrants of interest. That is where our answer, final answer, will come from. The rule that goes on in the third quadrant is theta plus 180. This is your theta you'll be using right here. This will give you obviously 30 plus 180 degree. And that will be what? 210 degree. So this is one of our answers. For our second answer here, we would have the rule that goes on in quadrant 4 is 360 minus theta. Our theta here is 30, so that will be 360 minus 30. This is 30, and then that will be 330 degree, which gives us our second answer. So you can see from here that we have this and this as both of our answers when we're dealing with sin theta being minus 1 over 2. But for sin theta being 1, arc sine of 1 is obviously 90 degree. So if you go on to investigate this, you go on to say theta equals to arc sine of 1, that will be 90 degree. So this is a positive 1. So obviously you are dealing with where is theta, where is sin theta, where is sine positive on your quadrant. It's obviously positive in both the first and the second. So we go on to identify that we have quadrant 1 and quadrant 2 as our quadrant of interest. For quadrant 1, I told you just to replace this in there. That will be theta equals to 90 degree. While for quadrant 2, the rule that goes on in quadrant 2 is 180 minus theta. That is 180 minus 90. That is 90 degree. So obviously, you can see that our final answer for this particular question, that's question number 2, is that our theta is 90 degree. That happened twice, and 210 degree and 330 degree. So that will be the final answer for this particular question number 2. All right, I want you to try this and tell me what your value for theta will be. Theta being values between 360 degree and 0 degree. So let me see your response in the comment section. I really hope you enjoyed this video. Thank you guys for joining. See you in the next video. Bye bye.